Is the fifth video for Unit 1, and I'm going to work through example problems 9 through 11. Now, I know I skipped a couple, but hopefully the end of the last video will help you finish through some of those. So I kind of skipped to some that were a little bit more difficult. Convert the following metric problems using dimensional analysis. 730 kilograms to micrograms. Okay. Now, if you notice that we're going from a prefix to a prefix this time, and when we do that, I'm going to highly recommend that you go to the base unit first, and here's what I mean by that. So if I'm starting with kilograms, as we had in the last video, we said that we wanted to make sure that we put that unit that we're trying to get rid of, we're going to try and put that on the bottom of the next conversion factor. So I'm going to put kilograms here, and I'm going to try, excuse me, and go to the base unit on tops, which is grams. So which one's bigger? Of course, the kilogram's bigger, so we're going to put 1 there. And it takes 1,000 grams to make a kilogram. Okay, so if you notice now, I'm in a position where my kilograms are going to cross out, but now I need to go from grams to micrograms. So grams are going to go on the bottom, and my mu, that's a mu, I'm going to copy that and see if we can put it in here. Yep. Okay, and a gram is larger this time, so I'm going to put a 1 down there. And it takes 1 times 10 to the 6th micrograms to make a gram. And now I've got the whole thing set up. And now that I have it all set up, then you can pick up your calculator. So I'm going to end up with 730 times 10. And if you look, I have an exponent of 3 here, times an exponent of 6 here. So I would add those two together, and I'm going to end up with 10 to the 9th. And I am in micrograms now. Let me see if I can copy that over, because that is not a very convenient unit to find, symbol to find. All right, and we would move this over, put my decimal point there, and then that means this goes up to, so my final answer is 7.3 times 10 to the 11th microgram. All right, let's try it again. For this time, I have units on top and on the bottom. In fact, this is a density. I've got centigrams per milliliter, and I want to change it to kilograms per liter. So I actually have to change 2 units now. I have to change 1 on top and 1 on the bottom. Now, it doesn't matter which one you start with, but just for giggles, I'm going to start with the one on top, and I'm going to go from centigrams to kilograms. And again, I'm going from a prefix to a prefix, so I'm going to go to the base unit first. I'm going to put grams on top. A centigram is smaller. It takes 100 centigrams to go to a gram. So I'm going to put that there. And 1 gram on top. Okay, so now I'm out of centigrams into grams. And now I need to go to kilograms. Excuse me, 1 kilogram on top, and I'm going to get rid of grams. So grams are on the bottom, and it takes 1,000 grams to get rid of a kilogram. All right, and so if you notice now, I'm 2 conversion factors into this, and now I've switched centigrams to kilograms. But I now need to change my milliliters to liters on the bottom. So I've got another conversion factor to go. Got 1 more. And this time, because milliliters are on the bottom and I need to get rid of them, I need them on the opposite. So I have to put milliliters on top of this conversion. And I want liters on the bottom, so I'm going to put liter on bottom. 1 liter, liter is the larger unit, and it takes 1,000 milliliters to make a liter. Okay, and now I'm all set, because now my milliliter here and my milliliter here cross out. I've got kilograms on top, and I've got liters on the bottom. So these, once I've got this all set up, I can do 27.5 times 10 to the, let's take a look. I've got an exponent of 3 on the top, and I've got a total of 5 on the bottom of my exponents. And since they're on the bottom, I'm going to subtract from that. So I have 3 minus 5, so this is to the -2nd. And I am in kilograms per liter. Okay, one more like this anyway. Okay, we are converting this one from kilometers per minute to meters per second. So let's just go ahead and get rid of the top unit first, okay, from kilometers to meters. So I'm going to put meters on top, kilometers on the bottom. The kilometer is larger, so I need 1,000 meters to go with 1 kilometer. Okay, so now I've got my top unit mixed or changed the way I need it. Now I need to get the bottom. Again, since minutes are on the bottom, I need to put minutes on the top of the next conversion factor. So I'm going to put minutes here, and what I want is seconds. So if we think about it, 1 minute, that's the larger unit, and it takes 60 seconds to do this. All right. All right, so on this one, I'm going to have to actually pick up my calculator here. 40.2 times 1,000, okay, and divided by 60. And I get 670 meters per second. Okay, I did notice up here that I didn't change this scientific notation like I should have, so I'm going to correct that up there. Put the decimal point, move it over 1, which means this is also going to change by 1. There we go. All right, I think we're all good there. Let's try number 10. Now we're going to go with multiple dimensions. So if I have something like centimeter cubed or a meter squared or something like that, we have to convert both of those meters. So what I mean by that is that this is centimeter squared. I can't just go from centimeter squared directly to meter squared. I have to actually do that conversion twice. So if I want to change centimeter squared to meter squared, I'm going to, again, set it up with a fraction. I'm going to get rid of one of my centimeters on the bottom, put meters on top, and 100 centimeters equals a meter. 1 meter on top. Now I got rid of one of them, right? So one of these centimeters will cross out, but not both of them. So I got to do this whole thing again. So I'm going to take this conversion factor, and I'm going to copy it, and I'm going to do it again. And if you look, now I've crossed out both centimeters, and now I end up with 2 meters on top, which is meters squared. So my answer, 547, 892 times 10 to the -4th. There we go. And that is meters squared. And again, we need to go back and correct this. We're going to move that decimal point over 1, 2, 3, 4, 5 places, which means this is going to go up 5. So this is actually to the first. Okay. All right, next one up. We're going to do this again. We're going to convert this to square meters from kilometers squared. So I'm going to put in my conversion factor here. There we go. Kilometers on the bottom, meters on top, and it takes 1,000 meters to make a kilometer, and that gets rid of one of them, but again, I got to do this one more time since we're in the second dimension. Okay, so since we're talking about area. Now, if this were volume, I want you to kind of think about what you would have to do here. If this were volume, you would have to do this 3 times, right? Okay, again, we multiply this out, 2.5 times 10. I've got an exponent of 3 and 3, so this is going to be to the 6th meters squared. Right. Almost done with this one. Now we're on part C, and we have decameters squared, and we're going to go to meters. So I'm going to use another conversion factor. We're going to put decameter squared, or sorry, decameter on the bottom, meter on top. And if you're unfamiliar with this, a decameter is actually 10 meters. So this is our larger unit on the bottom, and that means I need 10 meters on top. And again, since this is multidimensional, we need to do this again, all right? And so we've got 0.0045 times 10 and times 10. So we're going to end up with 0.45. And that is meters squared. Last one is 45 decimeters. And we're going to meters squared. Hopefully by this point, you pretty much have picked up on what we're doing. Decimeters on the bottom, meters on top. A meter is larger. I need 10 decimeters to make a meter. And again, we're going to double this up. Do this whole conversion factor again, just like that. And so now we're actually moving that decimal point over twice. So we're going to end up with the exact same answer as we had above, meters squared. All right, one last one. We're going to do example problem number 11. And then the last video, I'll cover some more difficult dimensional analysis word problems. Okay? All right, I have a box. It has a length of 23 centimeters, a width of 7,200 millimeters, and a depth of 5 decimeters. What is its volume in meters cubed? Okay. Well, the first thing you might notice is the problem here is I've got 3 different types of units here. I've got centimeters, millimeters, and decimeters. So I have to convert each one of those to meters first before I can multiply them all together. So I'm going to start with this one. I'm going to convert this one to meters. So that means meters are on top, centimeters are on the bottom. Meter is the larger unit here. And I need 1 times 10 to the second centimeters. So this is our length, and I've got 0.23 meters. All right, now we're going to convert our millimeters down here, our width. Meter on top, millimeters on the bottom. Meter is the larger unit, so it takes 1 times 10 to the third millimeters on the bottom. And I end up with 7.2 meters. All right, last one here for the depth. Conversion factor, meters on top, decimeters on the bottom. Meter is the larger unit. It takes 10 decimeters to make a meter. And so I've got 0.5 meters here. All right, now that I've got all of them converted, now all I have to do is multiply the 0.23 times the 7.2 times the 0.5. And that gives me a volume of 0.828 meters cubed. Now, I need to go back, though, and I need to look at my significant digits. If you look, I have 3 here. I have 2 here because those 2 zeros don't count. And then this one, I have 1 significant digit. So I have to reduce this to 1, which means I'm going to get rid of that 2 and that 8. And that is not quite right if I want to, well, 0.8, sorry, and meters cubed. There we go. All right. Now, last part of example problem 11 says, if the box above were filled with water, what would the water's mass be in grams or in kilograms? All right, now I know I rounded this for my previous problem, for my final answer. But since I'm using it again, I'm actually going to use what my calculator gave me. In other words, I'm not going to round it to start this. And this is in meters cubed, right? Okay, now when I look at the conversion factors that I have for water, there's a couple of them here that are going to be really helpful for me. A decimeter cubed, okay, let me put that, little decimeter cubed is equal to 1 kilogram of water. So that's going to help me quite a bit. And I also know that a centimeter cubed is a gram. I don't know that it really matters which one we do first, but I'm going to do kilograms because I think it's easier to convert to decimeters. So I'm going to convert this from meter cubed to decimeter cubed. And since this is in the third dimension, like I had mentioned before, we actually have to do this 3 times. So I've got a decimeter on top, a meter on the bottom. Meter is the larger unit, takes 10 decimeters, and I need to do this another 2 times because I got rid of 1 meter doing it this way, but I've got meters cubed. So there's 2 meters down, 3 meters down. Okay, so I have 0.828 times 10 times 10 times 10. So that gives me 828 decimeters cubed. Okay, that also means a decimeter cubed is equal to a kilogram. So that means I have 828 kilograms. Now, it didn't give me significant digits here, right? If you look, there's no significant digits in this problem whatsoever. But it's based on the answer up here, which only had 1 significant digit. So this is 800 kilograms, no decimal point. You could write that in scientific notation if you wanted to. And then for the last part of this problem, it asks for what is it in kilograms, or sorry, in grams. Well, we know that kilograms, it takes 1,000 grams to be in a kilogram. So really, my next part of this problem is 800 times 1,000. And this is where I am going to ask you to use scientific notation. Anytime you're really going out more than 3 zeros in either direction from the decimal point, then I'm going to ask you to do that. So this is 8 times 10 to the 5th grams. Okay. Again, I hope you found that helpful. And again, if you're having difficulties with any of these conversions, please come see me. I am happy to help anytime. Okay. All right. Take care, and I will see you soon.